Hey everybody, this is Stephen Feuerstein, Oracle Developer Advocate for PL SQL, and join with me Chris Saxon, Developer Advocate for SQL and Database and so on. You've probably heard me speak before, and you might be saying, wow, Stephen, you not only have a beard, but your voice sounds funny. My voice sounds funny because I'm losing my voice. I'm sick. So Chris has graciously agreed to step in and do the presentation today, even though I'm the one that did the slides, and they're not nearly as nice as his slides. So what I'm going to do is turn it over to Chris. I'll watch the chat line, Chris, and raise questions now and then or put in my own 2 cents. But otherwise, thank you so much for covering for me.
It's no worries, Stephen. Happy to step in. Hope you're feeling better soon. So let's jump over to the slides, and hopefully, as Stephen says, you'll keep an eye on chat, and I'm sure you'll chip in with your 2 cents every now and then as well. So today we're going to be looking at building APIs in PL SQL. So how you do it, what's the process, and so on. So we'll start off and say building APIs in SQL. Let's cover the different types of API you might want to build. So we've got a few here, and you might think of a few that you've got as well. So as I'm going through this, if you think there's more that we've missed, please put them in chat. It'd be good to get a bit of a discussion going around this. So to start off with, we've got transactional business APIs. So this is where the API represents something that the user is going to do, or probably the user is going to do. Things like creating an order, pay an invoice, create an account, reset their password. So doing an action which is going to change data in your tables. Could be one, could be many. They don't really know, they don't really care. Point is, it's around a business functionality, something that the consumer, the customers of your application, whoever that is, they're going to think, well, this is what I'm doing, and that's what the API represents. So that's business transactional APIs. Might only change one table, but probably will involve a few. So that's about writing data to the database. But a lot of databases tend to do a lot of reads. A lot of the queries are looking up information, things like viewing my orders, searching for products, seeing what my unpaid invoices or outstanding balance is, that kind of thing. So these are query APIs. So you might have just something like pass in my user ID to get my recent orders, or it might be quite complicated search functionality. I'm searching for products which cost less than this and are this color and have these various properties. So there's various parameters we might accept. The key point is we're going to be passing back some kind of array of results. So depending on what they've searched for, there might be nothing, but it could be a large number. So you might need to think about things like pagination here. How many results are you going to send back to the client? If you've got a product catalog with thousands of things in it, where are you going to put the cutoff? Are you going to put a cutoff, let's say 10 rows that they get in a single pass? How are you going to manage your pagination if they want to get the next 10 rows, that kind of thing? So that's query APIs. You're not changing any data. All you're doing is running a select, maybe a couple of selects, and returning the results in whatever form that the client requires. Next thing we'll look at is another way of modifying data. So these are kind of CRUD APIs, table APIs. So here, this is just functionality related to a specific table. Things like insert, update, delete, your basic operations. And these are just kind of little helper functions, just make you a bit more productive, make it easier to get things going. Tables can get a lot of columns in them. Sometimes they can have, tens, hundreds of columns. Typing out all the inserts for these can get quite tedious after a little while. So table API, you can have various tools that can auto-generate them. I believe someone on the call might have spent some time doing this, Stephen.
Certainly have.
Certainly. But these are just kind of utility functions, and then quite often you might build these and then have business APIs over the top of them. So you have a business transactional API, which would then call table APIs underneath. So those are the kind of main APIs which are actually working with data. One of the type that we've come up with, you might have, is kind of business rule or logic encapsulation. So these might be utility or helper functions for things to help you manipulate strings or format them in a certain way. You know, maybe you need to display customer reference numbers in a particular format. So you've got utilities that do that. Or maybe it's kind of more complicated business rules, checking whether customers have exceeded their cut credit limit or what the credit limits are, can they place particular types of orders. So here you're not really changing any tables. You may or may not be querying them, but you're doing something which is kind of giving like a true-false response, probably to say whether or not someone can return, or utilities would just help people manage the application, understand their data a little bit better. Okay, I see a comment from Jeff Kemp: custom will take the APIs plus transactional APIs for the win, and then ducks and runs. Care to expand on that, or anyone else got any other opinions on these APIs?
I'll just put in a comment alongside what Jeff was saying there. I'd put out a chat message about we'd probably at least have a vigorous discussion about Tappy. So for a long time, I offered tools to build Tappies, and there are a number of them out there for PL SQL Tappies and others. And some people, for example, famously Tom Kite and Bryn Llewellyn, really, really hate Tappies. And part of the issue around Tappies can be that if you generate a Tappy, you generate an enormous amount of code. I built applications in which every table had a Tappy. Each Tappy had literally dozens and dozens of subprograms, and we might only use a small fraction of them. So that's one of the problems with Tappies that you can get into. And the other is that they tend to think that you want to work at the transactional level, not at the individual table level. And it's true that many, many operations only happen at the transactional level or as part of a transaction. And to me, it's more a matter of where you've gotten value. I've gotten lots of value out of Tappies, partly because it gives me a starting point, and then I don't write the insert into the table. I'll call the insert procedure, and then later on, what was a single insert becomes a larger transaction, and we can still use that same insert procedure as the focal point for developing out the functionality. I believe that what Jeff meant by customizable Tappies, and Jeffrey, I'm sorry if Jeff is not an appropriate nickname, is that you generate the Tappy as a starting point, and then you cut out all the stuff you don't need, or you go and make changes to it. And I think that's a great plan as well. Please continue.
Yes, no worries. So if anyone else has got any other comments on the Tappies or transactional APIs, then please share them in the chat. We'll pick them up as we go along. And as I said, if you've got any other types of API that you can think of, specifically we're talking about database development here, or PL SQL development. Arguably there's things called orchestration APIs where the API isn't really doing anything itself. It's just bringing together multiple calls, but that tends to happen more at the middle tier layer where you're calling multiple backend services or something like that. So if you've got anything else you want to throw into the mix, or want to add anything to the Tappy versus transactional API debate, then let us know in the comments. Otherwise, we will start moving on and talking about the building blocks of APIs in Oracle Database. So what you could do is you could write a PL SQL function and procedure standalone for every unit of work that you need to do. So you can just say, here's my create order function, here's my view product list function, here's my reset password procedure, that kind of thing. But it's much better to use packages. Okay, so another comment come in from Jeffrey. Found a lot of value in using Tappies that provide bulk insert, update, delete operations useful to be called from transactional APIs that provide the orchestration. I think that's kind of what Stephen was saying, is like you get the table APIs to handle the boring bit of the code, typing out the insert, and then bring them all together with the transactional API. If I'm misquoting you there, Jeffrey, then please correct me. Or if...
I'll be Jeffrey's voice today. Lucky
Yeah.
Jeffrey. So I think also what I take away from Jeffrey's point there is that one of the nice things you get out of generating your Tappies, even as a starting point, is you don't write a bunch of that code. And he's talking about here taking advantage of for all and bulk collect. So building out a for all statement that has the save exceptions in it, that has the exception handler in it, the things that you might not as a developer take the time to do on a day-to-day basis in terms of your standards for writing your Tappies. or writing your APIs, that's where these generated low-level pieces can really come in handy as well.
I think what might be more interesting these days is, everyone loves JSON. It's becoming a very common way of certainly interchanging data between services, between your application and your back database. It may be that you receive a JSON request from the application, which you need to then store in database tables. And you could also build APIs, TAPIs maybe, which do use JSON table to convert those to the inserts. I'd be interested to see if anyone takes that up or thinks that's a valid way of doing things, because there's a lot of power there in terms of if you split out the JSON document into the bits that are needed for each table and then do the conversion so that you can leverage the powers of SQL there. Okay, so let's return to the kind of discussion about APIs and packages. So as we're saying, these are the way you really should get the package going. Oh, Michael Moore, I'm working on some JSON APIs now. Sven, agree with JSON, often write APIs to convert PL SQL collections to JSON, and even if it's just for logging purposes. Okay, that's interesting, Sven. So you is that data you're passing back out of the API or passing back or receiving from the client to convert to JSON? And Michael, anything you can add on your experience with working with JSON APIs or things that people should watch out for?
And by the way, if you want to unmute yourself, which you can do, and talk as opposed to chatting, typing in the chat, that's fine. Yes,
it's much more interactive and interesting if you can actually talk to us rather than we wait for you to type as fast as you can. If you're happy to chat, just let us know and we'll unmute you. Okay, so let's keep going. Let's get back to the packages. Just as I say that, Sven jumps in. I say, just to trace what values I have in my sometimes fairly complex collections, I convert them to JSON and write them to logger tables. Okay, so you're just taking all the values that you're processing intermediately and then logging them so you can view later. That's your instrumentation, right? Yes. Okay. From Judith. In a real-life application with a table have many columns, it may be true that there are not too many types of inserts to that table, but it's very likely there are lots of types of updates of different columns, combinations of them. Is a TAPI supposed to contain all these types of different update statements? Wouldn't make the caller transactional API too cumbersome. So now this is an interesting, and I see Stephen's coming up, so I guess he's got something,
well,
something to say here.
Just the classic questions that come up around TAPIs and have been for decades. So Judith, yes, that's right. There's generally one insert procedure, and then you'll just provide the values you want. There could be multiple inserts depending on how you've got default set on the column values. But you're right, with updates, you could try to come up with a generic update. I've had my fun doing that, and for those of you who've been around Oracle long enough, you might remember the case designer TAPI packages and how they would have a flag for each of the columns indicating whether or not a value is being passed. My feeling is that, yes, there are a number of different updates. It's not like there are usually going to be thousands of them. So you will end up with multiple update procedures. You'll rationalize them and refactor them as much as you can to not have extraneous close duplicates. But yes, the idea would be that if you take the approach that there should be no SQL outside of a PL SQL API, then you do have to handle those updates through a procedure, and whether it's a TAPI procedure or a, what do you call it, a XAPI procedure, a transaction procedure, yeah. It almost doesn't really matter. What matters is that it's all controlled through the API. But I think you will end up with a number of different update procedures. And then you might say, well, wait a minute, doesn't that make it too cumbersome? Well, the alternative is you don't use the API and you just have these updates all over the place in different forms. And that's way more cumbersome in the sense of managing that code and debugging it and keeping it up to current standards. So it definitely can get messy either way, but I'd say with the API approach, you're in control and you can manage it more easily.
So just want to add to that. So there was, I think it was in 12.2, we actually had some optimizations for updates. So quite often you're in a situation where you've got 20 columns in your table, so you have your update that lists all the 20 columns. But of course, a lot of the time, people only change one or two of them, or using this as a generic update anything. So all updates got to go through this process. And if you update every single column, even though nothing's actually changed in most of them, that can end up generating a lot of extra redo on your database. So there was an optimization for this, and I think it was in 12.2, where we said, well, if you're updating something to itself, the value hasn't actually changed, then we optimize away how the redo and so on is handled. So you can have these kind of less cumbersome. You could have a generic update which receives a record type, for example, and does set the record. So you're in theory updating everything, but in practice you're only actually changing the columns whose values have changed. Or you probably will have some specific updates for things like set order status, or some things where you've got a workflow and you're going through a series of particular things. Okay, so Jeffrey's back. He's gone to Jeff. So, so most tables only need a single update procedure. More complex tables typically have groups of columns that are typically updated at the same time. Callers would choose to update the procedure most appropriate for them. I'll occasionally add a new update procedure for particular purposes. Most complex TAPI I've worked with had maybe 7 update procedure variations. Yeah, so I think that kind of echoes what Stephen was saying, in that you will get a few variations, and that's been my experience too, Jeff, in that you might have 1 or 2 forms which people can update anything on the top on the table. So you have to kind of receive all the columns because you don't know what could change. And then you might have a few more specific ones, which are things like set the order status to paid, set it to shipped, that kind of thing. So that's been my experience too as well. I don't know if anyone's got any other experience, then please share. We'd love to hear it. Love to see what people are doing in the real world outside of my little bubble in Oracle here. So it's be good to hear. Okay, so where were we? Let's get back to where we were talking. Packages. As we say, this is the best way to build APIs in Oracle database. Why? Well, there's 2 aspects to it. You've got the package specification, which is the interface. That defines how people are going to interact with your database, run their insert, run their DML, and you can also use it to define package constants and things like that. Within that, you can hide the whole implementation. So you can have lots of private procedures which are just not relevant. So something like create order is likely to affect 2 tables. Quite often you've got the order header and then the details, the order lines, or whatever you call them. So usually a create order API will update at least, or insert into at least 2 tables. So you've got your public create, and that, depending on whether you've gone table APIs or pure transactional APIs where you haven't done that yourself, you might have private procedures, or you might call off to another package. So there's a lot of benefits to using packages. And first is, it just makes it a lot easier to manage your code. So you could have a package which manages all customer information, another one manages order information, another which manages invoice information, and so on. This just makes it easier for you as a developer to understand where to go. You get the request, we need to update the invoice payment process. So okay, I probably need to change the invoices package, maybe a payment package as well, depending on exactly how you've logically split things, and so on. What this also can do is help simplify your privilege or permission management. So you can grant people execute on the package, and then they've got permission to do everything in that. So quite often people, certainly in kind of back-end roles, call centers, things like that, they'll have access to do things like manage customer information, so they're allowed to do things like update your address, maybe reset your password and so on. But they're not allowed to do things like play around with financial data, which belongs to the finance and accounting team. So they can't, cancel a payment, do reverse charges, that kind of thing. So by having them in packages which represent kind of potentially business functionality or what people are allowed to do, you can grant them access to that and manage them that way. The other thing is it hides the implementation. As we said, we've got the private procedure. So you've got your public interface, which says create order. It's up to you how you implement at the back end. That could be any old massive whatever. Hopefully you've got nice, clean code, but things could get complicated. And if you think at the very top level, something very common business functionality like create order is likely to generate activity in several tables of your database. So you've got the order tables themselves. Maybe you can update the customer as well in some way or another to say things like change their credit limit or stuff like that. You might generate the invoice, generate payment, transaction information, send note to the shipping or delivery departments. So one of the key business functionalities is likely to affect many tables one way or another. And some advice I was given many years ago was that all the functionality for a particular procedure or function should fit on one screen. Obviously, it's not always practical, but the kind of like the business logic should all fit in one screen. So if it gets beyond that, you should start splitting it out into separate procedures and functions. So you can use that. You can have your one high-level procedure or function that they call, and then in the back, split it out however you want, which could, of course, call other packages. Maybe you've got your customer-facing API, which represents the business functionality, and back-end table API, which is actually manipulating the tables. Or you can get a bigger screen. Yeah, there is still a limit to how much someone can process at once. Okay, another comment that's come in, I see, from Pete. Quick SQL is a handy way for creating simple tappy packages to play around with the concept. That's a good point, yep. So for those of you who haven't seen Quick SQL, it's a great little environment where you can just bash out SQL statements and get going very quickly.
And it's integrated into Apex now. So right directly from Application Express, you can use Quick SQL.
Fantastic, there we go. Okay, so another comment coming in from Judith. What about many variations of where clauses for updating her specific set of records? I guess that the API will always update rows based on PKs and for most types, probably using for all. So personally, in my experience, I haven't really had complex updates or complex where clause updates other than maybe one or two. So again, I don't know if anyone's got any other insight or stuff they want to add there, then please say.
Well, I think that's the classic example of where you're moving up from a TAPI to a XAPI, a transaction API. Or you could say that's a part of the basic TAPI set of updates, but it's not something you're going to generate since you have these very context-specific where clauses. So at some point, obviously, you say, let's say you were generating TAPIs. You don't change them. Fine, that's it. The TAPIs are done. And then above that, you would be creating your own custom procedures and functions inside your XAPI. And you might create your own separate update procedure. It doesn't even call the underlying update. That's fine. The main thing is that whoever manages the code around the data and has the privileges to do so, then is able to manage those SQL statements properly. And even if there are somewhat duplicate-like statements around, it's still a very contained environment. From Michael Moore, much more likely to get into where clause chaos with the select APIs. Yeah, that's for sure.
That's very, very, very true. We've had a few other comments come in as well. So Jeff, expanding more on his Zappies, I think we'll have to come up with an agree way how we pronounce this as well. We'll see, we'll have a vote at the end maybe, how we pronounce APIs. So I guess you're doing like a bulk collect in your outer, your business API, and that passes the array where you do a for all and the TAPI. That's what I'm understanding from what you said there, Jeff. So if you want to add anything.
That's a good idea.
Yep. And Sven, agreeing with what I said in that rarely, well, the updates typically it's just update by primary key, and it's the odd case where you have something a bit more complicated than that.
And I think Michael Moore's comment is really good too. It's much more likely to get into where clause chaos with select APIs. We have some wacky dynamic SQL to handle it. And one of the other things you get into with these kind of tappies is, do I make the switch and go to dynamic SQL? Because then, of course, you can have whatever different combination of columns you want with indicator flags, and you construct it on the fly. That's all pretty. It can be a lot of fun for developers. I would say that for production applications, it's a level of complexity that you might want to avoid unless you've got some really crazy requirements and there are literally hundreds and thousands of combinations. And it literally makes more sense for you as a developer to invest time in really solid dynamic API, essentially. You're almost always going to be better off going with static SQL and, copying and pasting procedures and making whatever minor changes are needed and refactoring and consolidating as much as you can.
Yeah, Jeff, I think I avoid dynamic SQL as much as possible, which is something I agree with. Yes.
You should only use dynamic SQL if you need to use dynamic SQL. And one of the needs is our level of dynamic requirements is so large that we could write it in static SQL, but it's simply cost effective, productivity effective to go with dynamic. Otherwise, if you can do it static, do it static.
Yep, I agree. Okay, so let's move on the Y packages. Next thing I want to mention is minimize unit invalidations. So this is something we've gotten much better at over the versions in Oracle Database, in that when you make changes to a table, add, remove columns, that kind of thing, code that relies on it can get invalidated. So either because, particularly if you've dropped a column which code references, well, that's not going to work anymore. So we got much better about managing when we invalidate things, but if you've got schema level functions and procedures, so outside of a package, you can still end up cascading the invalidation all the way up the tree. And if that's all you've got, you can essentially break your application or make it temporarily unusable for a short period while everything revalidates. Packages break the dependency chain. So if you've got a procedure which is invalidated by some release that you're doing, it stops there, and then it doesn't cascade up to all the other packages that you break. So this just makes releases a bit safer and run into less issues with the existing state of packages have been discarded error, which any of you spent time releasing PL SQL will almost certainly be familiar with. See another comment come in from Judith. The where clause for updating one table may be the result of some logic involving related but completely different tables than the one being updated. This means that we need a superfluous query to be executed on the update target table just for constructing the input PKs for the update. Yeah, that's a good point. And I think I think certainly if you have got complicated updates, you probably would be looking at building them in their own transactional API one way or another. Experiences seem to indicate that you'll have relatively few of these. Obviously, everyone's different. Every application has its own requirements. There's always someone out there who's got 20 different types of updates with all sorts of weird and wonderful edge cases on them. But in general, this seems to be not something that people are worried about or struggling with. Okay, let's move on with the packages. And final thing I want to say on this is overloading subprograms. So as Stephen's put here, one of the best kind of clean API features. This is where you might have multiple ways that you want to call a particular procedure or function. So let's just talk about this a little bit more. So this is where you're doing the same functionality, but you'll have different parameters that you're going to pass to it, or maybe a different return type. So there might be some situations where you need to handle things differently depending on whether the input parameter is a date, a number, or a string, that kind of thing. That's probably like one of the classic use cases. You can accept these different data types. The end result, as far as the user's concerned, is the same, but you need to code them slightly differently, or you need to have different checks and so on. So what overloading allows you to do is handle the back end, the actual implementation of this, specific to each one, depending on how it needs to work. But the person who's consuming the API doesn't really need to be worried about the details. They just need to know, I've got this create order or whatever it is function I call, and person writing the code, so us at the back end, figure out the details, building the overloads as needed. As Stephen says here, don't overdo it. This can be really useful. Some people are going to get carried away and going, oh, we've got this, we can overload stuff, so we can just use this to kind of create really generic procedures which we pass anything to, and then do all sorts of crazy stuff at the back end to figure out what's really going on. That's not the right way to do it. That's more that if you've got different data types of parameters, or extra parameters which are required if you pass a certain data type in, it allows you to do that and have different types of implementations at the back end. Any other comments you wanted to add on that, Stephen? Or?
Well, I was actually going to show them one of my classic packages. Drive the point home. So let's see. Shall I do that? Let's see.
Yep. Okay.
I think I will.
I'll stop sharing for a second then.
Okay.
So while you do that, I see you just come in. Exactly, a transactional API can contain exactly any of the statements you need executed without necessarily limiting to very rigid TAPI constructs. Yes. Very true.
Right. So generally speaking, with TAPIs, it's often generated and it's the way it is. You don't change them. So that's what all your customization essentially moves up to the TAPI. And I'm going to post a poll on Twitter after this session to see how people want to pronounce that. So I just thought I'd show you something from long ago history of my work in PL SQL. So PL Vision is a library of packages I wrote maybe initially in 1996 as part of my Advanced Oracle PL SQL Programming with Packages book. And it was my attempt to kind of address the problem with dbms output.putline. So here's a little quiz. dbms output.putline has how many overloadings? How many overloadings of the putline procedure are there? I'll let you think about that and write your answers down as I go through this. Here's what I put together was the p.l. So p is the package, L is the procedure, so I only have to type p.l. And then I just went crazy on overloadings. Number and whether or not I want to show something. I don't, oh, right, I could override even if it's turned on. The date and a mask, a string and a number, a string and a date, a Boolean, string and a Boolean, et cetera, et cetera. And essentially the idea behind this, and even getting down to pass in a pointer to a file, and it will go and print the file. So conceptually, dbms output is all about putting stuff out on the screen. And instead of having it limited to essentially putting out a single scalar value, you could take that concept, and that's where I wanted to focus on the fact that the value of overloading is that what you're presenting to the user is a single name that represents conceptually an area of functionality. And rather than then having to remember to say, well, it's putline underscore varchar2, putline underscore file, it's just one name. They just remember that one name, they throw whatever they want at it, and the underlying code does the right thing. So that one of the things I really love about overloading is it transfers the burden of knowledge from the user to the developer. Now, whether or not I overdid it here, who knows, right? What's interesting is that with so many variations, it's not that hard to come up with scenarios in which things don't work. So here's an example of calling p.l. I pass a number and a date, and I got some information back. Let's see, this is run several days ago, but here it is, 104 March 19. If I try it this way and run it, let's see if it'll run. There we go. Now I just have to find the right place to slide this around. I think I got it. There we go. And now we get too many declarations of L match this call. So this is one of those classic errors that you get when you're doing overloading. And now what we could do is go back through the package spec and say, well, how many different variations of it are there and what's being called? And what's interesting here, I think, is that I'm passing a date and a number, but there are no date number combinations. There's number date, but there's no date number. So one of the other issues you get into with overloading is the implicit conversions. And what it basically, it tries to find a match for these two, and it'll do whatever implicit conversions are necessary to finally get to the point where it could do it. Then it might find more than one. And I think that it also gives you this message when it doesn't find any, which is especially misleading, but I can't say that for sure right now. So anyway, to me, what's important about this is the concept that you have an area of functionality that people need to use. It can have a variety of different inputs, but they don't have to worry about coming up with the right name. They just know conceptually this is the thing they want to do. And then you handle all the work on the back end.
So there's a comment come in from Pete. It says, you definitely want to call overloaded procedures with named parameters if there are a lot of similar overloads. Otherwise,
Excellent.
people are on the side.
Excellent point. That's right. Name notation really comes in handy that way, for sure.
Yeah.
But you never want your package to require name notation to be able to use it appropriately. That's just kind of rude.
Yeah. I think if you've got so many overloads that you require named overloads for people to do it, use it right, yeah. You've done it wrong, right?
Probably overdid it. That's right.
You've gone too far, I think. So okay, so let's bring this back up. Jeff's disagreeing. He requires named parameters everywhere. I guess we're not saying that you shouldn't use named parameters. I'm just saying that if you've overloaded to the point where the only way to use it is named parameters, then you've done it wrong.
That's exactly the point, right? You shouldn't get errors if you don't use name notation. Well, I guess an argument. Well, anyway, and Oren has a really excellent other use case for overloading, which is maintaining backward compatibility. So you're adding new parameters, and they can even be a new out parameter and out parameter. So what you want to do is have an overloading that doesn't have that additional parameter, so that your existing code works as is. And overloading can be very helpful for that. Yep.
Okay, so it'd be nice to have a flag or compilation settings to disable implicit conversions for a given PL/SQL unit or session. There is a warning, isn't there, related to
for implicit conversions? I believe there's a performance-related warning that will indicate if the compiler detects that implicit conversions are taking place. Yes. Mm-hmm.
And you can make them errors as well.
That's right. You can make them errors. And then Jeff says, using named parameters everywhere means you can safely add an overload and know it won't break existing code. Listen, Jeff, I'm not arguing against a great rule, a great best practice for a team being always to use name notation. It just happens to be one of those things that many people will not do because of the overhead of writing it. But it's a great idea.
Yeah, I agree with your principle as well, Jeff, that it's a good practice to follow. But I think as long as you're designing your overloads so that it isn't strictly you absolutely have to do it for it to work, then I think that's kind of the point I think we're making. All right then, so let's kind of finish up. We'll talk about some tips for some high quality APIs, and of course feel free to add your own at this point or disagree with anything we're saying here. So first up is just consistency about how you're writing them. You know, how are you naming your packages so you know what kind of code belongs in each. I remember years ago I worked on an application where we had APIs which were related to, or packages related to UI functionality, you know, widgets and things like that. So they had entity, whatever it is, UI, and then there was ones which were related to actually doing the DML, you know, the procedures which called stuff. They were entity name data, and then things which were like the query APIs, entity name and view, or whatever, I forget exactly what we called it now. And if you stick with that pattern, it makes it much, or a pattern like that, makes it much easier for new developers to join your team. They can kind of look at your code base, get some idea which things go where. Also helps you, you know, 6 months down the line when you come back to your old code and go, where was that procedure that I was going to be writing about, you know, managing invoices? Oh, it's likely to be in invoice data management or whatever you procedure management package naming convention is. Also things like be consistent about things like how you're handling your error. Ideally, you're using some kind of pre-built off-the-shelf error handling utility such as Logger, so you don't have to really worry about it yourself. But whatever approach you take to error handling, come up with an agreed way of managing it with your team and say, this is what we do with these type of exceptions, this is how we log them, this is what instrumentation we expect, this is how we return the results back to the client. So that way, when things, the people consuming, the UI developers, who may be you, maybe someone else entirely, they can expect consistent behavior. They know, well, if I get these type of exceptions, I can handle it this way, so on. And of course, think carefully about how you are managing your transactions. I'm not sure I want to get into the debate about where exactly you put commits in your code here, but I'll just make the point to remember that if you've got a commit inside your PL SQL within inside an API, you make it a lot less reusable. So, because it ends a transaction, so then you can't compose them together to form a larger business transaction. As I said at the start, something like create order is likely to involve changing many different tables in your application. If you've got your payment API, your invoices API, your order API, and so on, and all of those have got commits in them, you can't then write an orchestration API over the top of them, which handles create order as a single transaction. You've got to leave it up to the client to figure out how to bring them together if something goes wrong in the middle. So be very careful about where you put your commits in your code. Next thing, one overloading case that we haven't mentioned yet is particularly relates to the Boolean data type. So a lot of times you have functions which, is can customer place order, is order paid, that kind of thing, where you're just checking a status. And of course, if you return a Boolean, that's great for PL SQL. You can put it in an if statement. Not so great for SQL because then you can't call it in a select statement. You need to convert that Boolean to a yes or a Y or an N or a 1 or a 0 or whatever you've agreed to handle Boolean in SQL to look like. And finally, keep the packages themselves a manageable size. I've already said keep, individual functions and procedure roughly a screen. The overall package itself should be relatively small. I mean, relatively, there's no strict guidelines here, but if you've got a 30,000 line package, a couple of issues. As Stephen's put, it could take quite a while to actually compile that. But then it also kind of breaks the point I was making earlier about privileges. You can then grant everyone who's got execute privilege on that package can then do whatever the heck is in there, and it becomes much harder to manage your privileges. So if you can build certainly your client-facing business APIs around business functionality that represent privileges and things that people should be able to do, you can manage it that way. If out there you do have that monster package, which has got everything in it, there's been some enhancements in releases, things like whitelisting of procedures and so on, so you can help break it up and find a way to split it out more individually, grant the privileges and get more finer grained control over who's supposed to do what. Okay, anything you want to add, Stephen, on that? So I just see a comment from Sven. I use subroutines like do commit. The subroutine then has the commit and the flag, which influence and change commit behavior, which is especially useful for testing purposes. During the end test, I can switch off committing and roll back the test at the end. That's an interesting technique. It's not one I've seen myself.
Still is acting weird, and so I wasn't able to respond.
No worries.
So yes, one other thought about the overloading for native PL SQL and SQL. Again, I did write these slides, and there's a little bit of an error here in the sense that you can't overload. So going back to overloading, one of the things that can trip you up with overloading is you can't have the only difference between the two, say, functions being the type of data being returned. So if I'm returning a 1, 0 versus an actual Boolean true false for my SQL usage, you can't have the same name. And what I ended up doing, started doing, was taking the same name. Let's say it was maximum salary, and I wanted to read no, you know, am I getting the maximum salary? Yes or no? Then I would say get max salary is the Boolean function, and then get max salary underscore YN to return a yes or no. I found that was the most explicit way to make it clear in the name itself what it was doing. But it's actually not an overloading. That's, I think, the only comment I had to make.
Yeah. Okay. All right then. So I think that's what we had prepared in terms of slides. So at this point, see if we've got any more comments, questions. There was I noticed there's something Sven added in terms of table APIs, just bring the transactional versus table API debate back. TAPI stands for totally overrated API. I don't know if anyone else wants to comment or argue that in any further, or are we gonna...
Well, the only thing I'd say about that, because again, I'm over the years by being a strong proponent of TAPIs and having someone of the stature of Tom Kite saying they're stupid, it just wasn't a fun experience. And what I finally came to realize or accept for myself is that different programmers have different experiences, and what works for you, for whatever reason, may not work for others. So I found TAPIs to be extraordinarily helpful. Many TAPIs should have been zappies from the start. And in fact, in many cases, my TAPI procedures kind of grew into having multiple statements inside them. So maybe I was just naming it wrong all the time. But the bottom line to me is that what you want to do is control access to your data. And the best way to do that is through PL SQL APIs. And whichever approach you take and whichever mix of approaches you take, that's cool. Just make sure you're not letting everybody write their SQL all over their application, both in PL SQL and even worse, in higher levels of the stack, Java, JavaScript, etc.
Okay. So
one other thing with Sven's comment around do commit, I actually used to have a whole package. I think it was PLV commit, part of my PL Vision library. And the whole idea was that you never called commit the built-in commit in your code. You would call the PLV commit dot do commit. And it was for specifically one of the reasons that Sven mentioned, which is when I'm doing some testing, I might want to turn off the commit so I don't have to I could just do a rollback at the end of my test and then run another test, as opposed to refreshing my data set because it's been changed. So that was just one example of where I found that helpful. I think it's a relatively uncommon technique.
Okay, so we've had some more comments come in. I like Zappies, transactional business APIs. I don't like TAPIs. I think we have special use cases where they're useful, but not to generate them for every table.
And I agree. I used to do that. I don't do that anymore.
So Michael, kind of reinforcing what you said, I think, Simon, what works for many apps doesn't necessarily work for all apps. And there was a comment from
Jeff. Jeff had mentioned earlier that when it comes to commits, he prefers to let Apex handle the commits, both in the sense of the user handling the commits and the web level. Every action is a transaction. And then Karen mentioned that, but some things need to work both inside and outside of Apex. So having that flexibility with the on-off of a commit procedure could be helpful. It's a good point.
Yes. Okay. So anyone got anything else they want to add to that?
Apex in all stateless environments, says Judith, might require complex enough logic to handle optimistic locking scenarios, which is not always simple. Agreed. Yes.
Mm-hmm. Yes, handling optimistic locking is always an interesting thing, which a lot of people overlook.
All right. Well, I think that pretty well covers it, comment-wise. And now it's over to you. No,
it's over to you. Well, I think we've had a lot of good discussion. Okay, I think it's been interesting.
Excellent conversations.
Yeah.
And I think one of just maybe a closing comment on my part. We get a lot of pushback around using the database for business logic and essentially for APIs, right? The front-end developers simply want to execute the SQL through an ORM or through some other framework, or maybe hack it together themselves in JavaScript. And the funny thing is, they're big believers in APIs, right? They're all about APIs. But when it comes to the data, they don't seem to want to deal with it in the same way. And in fact, we would argue, and I think it's pretty clear, it's even more important to have a very strong, solid, secure, performant API for your data. And that just takes us right back to one of the core values of the PL SQL language.
Yeah. So yeah, I think that's a great point, Stephen. And I think perhaps potentially one of the nice things about things like ORDs or REST enabling your database is you can then kind of go, well, we're going to build these APIs and they're going to return JSON. And then, front-end developers don't even necessarily need to know you're building it with PL SQL.
Exactly.
All they know is, well, they've got a REST API they can call, it returns JSON. Okay, and that seems to be a world a lot of people live in. So.
All right.
Great.
Well, thanks for joining us, everybody. Thank you, Chris, for filling in. Obviously, my voice was okay for intermittent comments, but I can already feel it straining. In case you're thinking, Chris, you could have done this. But so thanks for joining us. Hopefully, it has been another useful office hour session. Let us know if you have ideas for future sessions. I did have a request come in through Ask Tom to do a session on ref cursors. So our plan right now would be for April, to talk about ref cursors in detail. But if you have some other ideas that you want us to cover, do let us know, and subscribe to a lot of the other office hours sessions as well. Thanks for joining. Take care, everybody.
Yep. Great to see you all. Enjoy the rest of your day.